In this video we're going to look at a basic data set. There are approximately 60 items in it, and we're going to look at ways that you can dynamically rank results from that data set. For example, to find out who got the largest score, who was in the top 10, who's the oldest, etc. So let's start really easy. We've got a column called age, and we want to find out who is the oldest athlete. Max will do that. It's called TBL data. You can see that at the top of the table. I made a little note. Using Excel tables makes it really easy to read and understand a formula. So we're finding the max, TBL data, column age. It's telling us that the oldest person is 33. However, if we want to do the second largest, or the fifth largest, or the 20th largest, then the max won't do. So large is great. So it will work to find out the first largest. It'll do exactly the same as max. Certainly doesn't have any benefits to using max, and the syntax is almost identical. The only difference is there's a second argument in the formula that wants to know whether it's the first, second, third, fifth, sixth largest that you want. So I'm just going to say 1. It's telling us the same as what max did, thankfully. And if I copy that, paste it down, I can change that to 2, 3, 4, whatever I want, and it will tell us what that is. Now that's going to be really useful for us when we want to do things such as top 5, top 10. Starts getting a little bit more complex when you want to find out who is the oldest athlete. So we know that the oldest athlete is 33, but we don't know who that is. The way to do that is to use the max to help us find that. Now one thing I just want to do before that, I want to find out how many athletes are 33. If it's more than one, then we've got a different problem, but let's just check that out. In the age column, count the number of times that there is a 33. Thankfully there's only one, so we can now go and look for who the oldest athlete is. Index is where we need to start. What do we want to look up? Well, we want to look up the name. How do we identify the name? Well, we look for the maximum age. So match is good for that. We need to give the index function a row number. So the match gives us a row number based upon whatever lookup value we put into it. So let's look up 33. In the age column, 0 tells us it's an exact match because that's what we want. And if I hit enter, we see Curtis is our oldest athlete, and I can see him there in row 15. He is in fact our 33-year-old. Now this formula is a little bit fragile at the moment because it points to H7, and if H7 isn't there, then we're in trouble. So what I'm going to do is just go up into that formula and copy it, and make our formula a bit more robust. So instead of having H7, I'm going to put the entire formula in its place. Now that means that I can get rid of the 33, I can get rid of this, and it will still work. If I copy that, and if I paste that down here, we've got the basic outline of who was the second oldest athlete, but we're going to have to replace a part of the function with something else. So we did the second largest or second oldest calculation up the top here using the large function. And so instead of this section here, the lookup value is in fact that. So we can see that Lily is the second oldest, and she is 32.2 years of age. So let's just see if that is in fact true. This list is alphabetical, so we should be able to find Lily, and we can see that she is in fact 32.2. So that's great. We've got oldest and second oldest. So far these functions are all relatively simple. Index match, large, small, max, those sorts of things are really fundamental formulas that if you know them you can pretty much apply them to all sorts of situations. Now this starts getting a little bit more tricky. The first thing that we want to do to find out who the top 10 are is to find out what the top 10 scores are. Now I've been through this already and I've got some red text here, so it's going to be useful to refer to that in a second, but don't be confused for now. We use the large function. We want to find out the top 10 performance scores. So in our table of data, we go to performance score, and we could either type a 1 in here, or I could refer to this cell and hit enter. The reason to refer to that cell is that I can now just drag it down and not have to repeat that formula 10 times. Now you can see the value of this red text. We've got 2 with 95, 2 with 89 and 2 with 87, and that's going to give us a bit of a problem when we do the first crack at this formula. There's a few ways that I've solved this problem over the years, but we'll get to that in a second. First thing is just to do our index. So this is exactly the same trick that I used to find out the oldest and the second oldest athlete. So hopefully that process was relatively straightforward. Now if I double click and copy that down, it's given us the 10 names, but the weakness of this method is that it can't handle duplicates. And as you can see here, both the second and 6th and 7th and 8th and 9th are ties, and so it pulls out the same name for both of them. Now in the case of 95, or the third place score, we want obviously a different name to be extracted, because that would certainly be more accurate. Now there's a couple of ways that I've solved this in the past, as I mentioned. One way is really easy to understand, but it does require on you creating an extra column. I'm just going to call it performance helper to indicate a helper column. The row formula, I just click on, let's say this, it's going to tell us what row number we're in, which is 5. Not super useful on its own, unless you're using it in an index match function, but what we can do with it is I can divide that by 10,000, and it gives me this minute fraction. If I click on performance score and I add a minute fraction based upon the row number, we now get 83 plus a tiny fraction. That tiny fraction isn't enough to adjust the score of any of the values, and so if I selected this entire column and I decrease the decimal down, it would be identical to the performance score column, but it's not. it is actually different because it's now got a slight fractional difference, and that means nothing will be a duplicate anymore. So if I repeat this process, just to the side here, I just need to change that to be the performance helper column. Don't worry about those NAs for now, but you can see that's now extracting those and that they're all different. If I change this also to performance helper, double click, send it down, we now get differences. So we can see that Nate and Eric are different, and therefore instead of having Eric twice, it's got two people, and the same further down. Now the way this will work is that the higher the row number will be, and the higher the person gets ranked. So you just have to be a bit wary if you're going to use this trick. I don't think it matters, because as long as the top 10 are being extracted, that's okay. But you can even reduce that down and produce your chart and tables and stuff like that. But that's a really useful way. Just going to write a little note about that. So that's definitely an improvement. Just going to drag that across to create a little bit of room for us. When I've been trying to solve problems like this before, I have Googled all sorts of different options and seen some really interesting and creative solutions that I've been able to apply when I'm doing ranking with duplicates. So here's an example of a formula that will work for this circumstance. Now the first thing we need to make this trick formula work is to know what is the 10th largest, because that will be a useful part of a criteria that we'll use to extract the top 10 scores. Next thing we have to look at is to see how many scores are equal to or greater than this 10th largest one. So when it tells us 11, it means that there's clearly an 11th score equal to the 10th score. So that's what that means. Why don't we test that out? Drag that down. There we go, we can see that 10 and 11 are different. So the really interesting solution is that what I've pasted in here. I'll quickly try and run through it. The first part of it is telling us that don't return any values once we've got the amount that we want. So that basically says if the row counter is higher than the number of names who are greater than the score, then don't do anything. You could do without that, and the only downside would be that you might get an error at the bottom of the table if you dragged it beyond 11 names. The next part is that we want to find our answer in column A. Next part, the small, says that we want to find the first row where the performance score is equal to 97. So this is in case there's more than one. If there is more than one, the second part of the if equation finds the second or the third or the fourth one. So this will be a dynamic formula that would allow 3 or 4 or more people to have the same score. Something not to forget is that this is an array formula. So when I enter it, I hold down Control Shift, and there's a curly bracket before the if and at the end. And when I pull that down, we get our 10 names. Now, very interestingly, they are slightly different ordered to how we did it with our helper column. That's because it's finding the first of the 2 duplicates and then the second one, whereas this formula is finding the second one and then the first. So, same names, just slightly different organized. And if I pull this down to 11, pull that down, and pull that down, we'll get the names that we expect to get. So I really like that. It's a very clever formula. The problem is that it is an array, and array formulas tend to be A little bit problematic sometimes, they can be thirsty, but we're only doing 10 rows with this array formula, and so it's not going to slow our machine down. But if we were trying to do this on 1,000 rows, then it might not be so good. Alright, so I've gone through some of the standard formula options, and they're the kinds of things that I would normally do if I was building a dashboard, because it's what I'm most comfortable with. The next thing I want to show you is something really obvious. If you work in accounting, you are probably a whiz at pivot tables and find a whole lot of formulas to be a waste of time. What I'm going to do is click Insert, choose Pivot Table, put it on a new worksheet, and just open this up a little bit. We want names in row, and let's do performance score and the values. And when I click outside of that wizard, the wizard disappears and we've just got our data set. It's not exactly how we want it, but what I can do up here is choose a value filter and choose top 10. An extra filter wizard box appears, and it allows us to define it a little bit further. So we want the top 10 items based on performance score. Cool. And there it is. It's not sorted in order, but we can take care of that, like so. Now if I was being a stickler, I would go into the pivot table options and get rid of that grand total. But there we go, a pivot table that only took a few clicks. A hell of a lot easier, and if the data changes you can refresh. So let's try that out. So let's try Amanda Baker, performance score of 83. Let's give her 99, and Amelia 98. Hopefully we've noticed that all of these formula have dynamically updated, which is great. Pivot table won't by default, but if you right click on it and choose refresh, it will update. So pivot tables are pretty good, and if we wanted to, we could open that wizard up again and say that we want top 15, and it would automatically expand. So we've got plenty of flexibility within pivot tables if we're more comfortable using them. Just as an aside, while I was researching for this, I came across a really cool formula that every once in a while will be useful. And it might be, what is the average score of the top 10? And what we can see inside this is a really clever array within the large function. So average of the large, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if we click inside the formula, it highlights a section, and if I hit F9, it converts itself to the values. And if you think about the average function, it's pretty easy for the average function to deal with that. So putting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inside curly brackets in the large function extracted all those numbers. So I thought that was really cool, and I decided to include it. Now the last thing I want to do is really cool. Excel has been working on some dynamic array functions. I want to give you a little demo of them. Certainly just getting started with them. I'm not an expert yet, but you'll find some pretty cool videos online about it from genuine Excel gurus. Now, if I type filter, this is a new function, and if I open brackets, it is saying, what is our array? Well, I'm just going to include the entire table. Now I need some criteria here. That's what include is asking me. So I want to extract everything where the performance score is greater than or equal to this number. I could have clicked up here, or I could have typed in a further function. But let's just leave that for now. If I close brackets, there's not a lot to that formula, but see what happens. It has extracted everything, one formula, across all of those columns. And that was even more amazing, is that we could do a second dynamic function to sort that in a particular order. So at the moment it's just extracted them out in the order that they appear in the table, which is alphabetical. You can see it's actually one formula and it is spilled. That was the little warning message. It is spilled out of the cell and across 6 columns and a bunch of rows. If I put sort around the outside, that is our array that we are wanting to sort. How do we want to sort it? We have to tell it the column number that we want to sort it by. So if we look in our table, 1, 2, 3, 4, name, position, age, performance score. So column 4 is the index of the table that we are using to sort by. Do we want it ascending or descending? We want it descending, highest first, close brackets. Now if I hit enter now, it has now sorted it in the correct order with all the columns with one formula. So that's pretty fantastic. Now if you want a bit more info on dynamic array formulas, then chuck it into YouTube or Google and you will find a whole lot of hits and very recent videos where people are explaining how these formulas work and some of the cool things you can do with them. Now a column or a bar chart doesn't matter too much. When you've got long names, it can be useful to do a bar rather than a column, but that's okay. Now to demonstrate how things might look, I'm just going to change our card type number with a random number between 33 and 99, and when I double click and send this down, what it will do is be a bit volatile, and volatile means it will update every time I do something or hit F9. So I'm going to hit F9 and see what happens. Thanks for watching. If you want a copy of the file, please let me know and I'll send it through. Thanks.